These next lessons are going to give us an introduction to proof, formal proof with deductive reasoning. But before we get started, I want to show you a little video that introduces the idea of proof, and special thanks to Scott Kennedy for his work on this video.
What is proof, and why is it so important in mathematics? Proofs provide a solid foundation for mathematicians, logicians, statisticians, economists, architects, engineers, and many others to build and test their theories on. And they're just plain awesome. Let me start at the beginning. I'll introduce you to a fellow named Euclid. As in, here's looking at Euclid. He lived in Greece about 2,300 years ago, and he is considered by many to be the father of geometry. So if you've been wondering where to send your geometry fan mail, Euclid of Alexandria is the guy to thank for proofs. Euclid is not really known for inventing or discovering a lot of mathematics, but he revolutionized the way in which it is written, presented, and thought about. Euclid set out to formalize mathematics by establishing the rules of the game. These rules of the game are called axioms. Once you have the rules, Euclid says you have to use them to prove what you think is true. If you can't, then your theorem or idea might be false. And if your theorem is false, then any theorems that come after it and use it might be false too. Like how one misplaced beam can bring down the whole house. So that's all that proofs are, using well-established rules to prove beyond a doubt that some theorem is true. Then you use those theorems, like blocks, to build mathematics. Let's check out an example. Say I want to prove that these two triangles are the same size and shape. In other words, they are congruent. Well, one way to do that is to write a proof that shows that all three sides of one triangle are congruent to all three sides of the other triangle. So how do we prove it? First, I'll write down what we know. We know that point M is the midpoint of AB. We also know that sides AC and BC are already congruent. Now let's see, what does the midpoint tell us? Well, luckily, I know the definition of midpoint. It is basically the point in the middle. What this means is that AM and BM are the same length since M is the exact middle of AB. In other words, the bottom side of each of our triangles are congruent. I'll put that as step 2. Great! So far I have two pairs of sides that are congruent. The last one is easy. The third side of the left triangle is CM. And the third side of the right triangle is, well, also CM. They share the same side. Of course it's congruent to itself. This is called the reflexive property. Everything is congruent to itself. I'll put this as step 3. Ta-da! You've just proven that all three sides of the left triangle are congruent to all three sides of the right triangle. Thus, the two triangles are congruent because of the side-side-side congruence theorem for triangles. When finished with a proof, I like to do what Euclid did. He marked the end of a proof with the letters QED. It's Latin for quod erat demonstrandum, which translates literally to, what was to be proven. But I just think of it as, look what I just did! I can hear what you're thinking. Why should I study proofs? One reason is that they could allow you to win any argument. Abraham Lincoln, one of our nation's greatest leaders of all time, used to keep a copy of Euclid's Elements on his bedside table to keep his mind in shape. Another reason is you could make $1 million. You heard me. $1 million. That's the price that the Clay Mathematics Institute in Massachusetts is willing to pay anyone who proves one of the many unproven theories that it calls the Millennium Problems. A couple of these have been solved in the 90s and 2000s. But beyond money and arguments, proofs are everywhere. They underlie architecture, art, computer programming, and internet security. If no one understood or could generate a proof, we could not advance these essential parts of our world. Finally, we all know that the proof is in the pudding, and pudding is delicious. QED.
All right, so let's get down to the basic information about proof that you're going to need to know. Basically, a proof is a convincing argument that uses deductive reasoning. But the biggest part of it is every single statement you make has to have a justification or a reason backing it up. And so here's some properties that are going to help you to do that. These are things that you learn in algebra, and you do want to have these memorized. They're going to be really helpful to help you as you start to justify your statements. So let's just read through them. We've got, first of all, we've got the addition property. The addition property is that property that allows you to add the same number to both sides of an equation. You can add the same number to each side. So if x equals 2, and I decide I want to add a 4 to both sides, that becomes x plus 4 is equal to 6. So 4 got added to both sides. Same thing works with subtraction. You can subtract the same number from both sides of an equation. You can multiply both sides of an equation by the same number. If z is 5 and I decide I want to multiply all that by 8, then I have to multiply 8 on this side with the z. That gives me 8z. And I have to multiply it on the 5 side. 8 times 5 gives me the 40. But just has to happen to both sides. If I'm dividing and I want to do it on both sides, that's legal too. Dividing by the same number will keep the equation equal. Other than 0, we can't divide by 0, that's undefined. And then this property here, the substitution property, isn't so much what we do to both sides of an equation, but that's the thing that allows us to exchange parts of expressions with other values. These are the things we plug something into. So if we have an equation that says y equals 3x plus 5, but we know x is 2, that's where we get to replace and put the 2 in the spot for the x and change that equation to say 3 times 2 plus 5. That's substitution. You already know those, you've worked with them. Now we're just going to name them each time we use them. Now some other properties, and these are probably not as familiar, but these are good, important ones to memorize. The first one is called the reflexive property. The reflexive property says that anything you have is equal to itself. Numbers are always equal to themselves. So simply like the number 5, guess what that equals, guys? The number 5 is equal to the number 5. Wow, no brainer. But also any object is congruent to itself. So on our geometry, we have angles or segments. Angles and segments are always congruent to themselves. So here we got angle Z is congruent to, yep, angle Z. So think reflexive property. That's like reflection in a mirror. Think you're looking at yourself. All right, the next one's the symmetric property. Symmetry, that's like your face. Your left side of your face and your right side of the face. Those are the same. So this is saying that you can change the order of an equation or the order of congruence. If I want to say that A is equal to B and you want to say no, B is equal to A, well, we're both right. If A is B, then B is also A. And the same works with angles. If angle R matches angle Q, then it stands to reason that angle Q matches angle R. The last one, so transitive property. This one's my favorite. I love the transitive property. If you have two values that are both equal to a third value, then they're going to be equal to each other. One way to think about this would be to think about like shoe sizes. If I can wear my sister's shoes, but my sister can wear my mother's shoes, then that means that I can wear whose shoes? I can wear my mother's shoes. So mathematically it reads like this. If A is equal to B and B is equal to C, both of those are true, then A has to be equal to C. This should look a whole lot like that property, that law of logic that we learned, the law of syllogism. B here is the middle guy, and we can skip over the middle guy and go straight from A equal to C. And the same thing works with congruent objects. If 1 and 2 are congruent, and angles 2 and 3 are congruent, then yep, we can skip right over angle 2, and we can say angle 1 is congruent to angle 3. So those are the properties that you're going to use as you justify statements, but also the other things that justify statements. Definitely don't forget about the distributive property, where you take a number and multiply it through an addition. And the postulates we've learned. We learned segment and angle addition postulates, things that allow us to add and subtract angles together. And definitions. Definitions are also facts, and those can justify things. So definition of midpoint, definition of bisect, supplementary, complementary, linear pair, and this list goes on and on and on because we're going to keep adding new facts as we go through the year. But anything we know is true and we've justified it, we can use to justify other statements. That's the beauty of deductive reasoning. Let's try some examples. We're just going to support the conclusion with a justification. So you're going to find these properties on the other side of your note sheet. We're given that 6x plus 2 is equal to 12. So we can conclude that 6x would be equal to 10. What happened? Well, I see on this left side that the 2 has disappeared, and that's happened by subtracting 2, so I have to do it to the other side, and that definitely gives me 10. So this was the subtraction property. Okay, going on. I'm given here that x is equal to the measure of angle C. And then I'm concluding that 2x's would be equal to the measure of angle C plus an x. So what happened? How did I get from x to 2x? Well, I would think that I multiplied by 2. Did the same thing happen on this side? What happened to this side? I added x. So did I multiply or did I add? I need to be careful. In this case, I actually added x. If I see the x on the left, if I add another x to that and combine them, that makes 2x. So rather than say multiplication property, I want to say addition property. And x was added to both sides. So this is addition property. Alrighty, number 3. We have angle DOG. Let's read that dog. Angle dog is congruent to angle cat. And angle cat, well, he's congruent to angle rat. So this is the middleman guy. Both of these angles, dog and rat, are both congruent to angle cat. So let's get angle cat out of that, and let's just say angle dog is congruent to angle rat, which is our conclusion. This is called the transitive property. Up to number 4. We're given that 2 angles, angle 1 and angle 2, added together make 90 degrees. So what are they? Complementary. And our conclusion is that angle 1 by itself is equal to 90 degrees minus angle 2. Oh, let's break this down. We started with angle 1 and angle 2 together, and now we're just down to angle 1. So essentially I have lost or subtracted angle 2. Angle 2's been subtracted. Was it subtracted also from the other side? Yes, it was. Now it's showing up over here subtracted. So this is the subtraction property. Here in number 6, we start out knowing that Q minus X is equal to R. And our conclusion is that if I take 4 times Q minus X, that's equal to 4 times R. This one's not too tough. What happened on each side is that we got a 4. We didn't have a 4 before, and it's been multiplied on both sides. So this is going to be multiplication property. Multiplication property. Finally, the distance from R to T is equal to the distance from R to T. Huh? If I have a picture, the distance from R to T, let's call this R and this T. So this distance here is equal to the distance from R to T. We're just saying the same thing twice. This guy's R to T is equal to itself. You are equal to you. Look in the mirror. This is reflexive property. Now, reflexive property might seem kind of, why are we wasting our time? That's so simple. But believe me, this is going to come in handy as we go through the year. You're going to learn to love the reflexive property. Okay, I'm leaving some of these for you to try. Give these 4 a shot. Again, you're going to find your answers on the front with all those different properties. We're going to look for a justification on each one. How do we go from the given statement to the conclusion?